Okay, let's begin with the classification of data now. Okay, so with a bit of a break, we can start here. Um, okay. So take care of your things. So there is also a good website for all of you, which I would tell that is 365 Data Science. So go to 365 Data Science and try to see the concepts of data analytics. I took the figure from there. So measurement levels, measurement levels. So types of data. What is the data? Data are set of recorded measurements. Okay. What are the types of data? Data can be categorical. Data can be numerical. Okay. Two types. What are the categorical data? For example, your eye colors. Anything else? Mm-mm. Cards. Cars. Okay. Yes. Categorical. Okay. Anything else categorical? Flowers. Okay. Huh? Anything else? Onion. Names. Oh, colors. Okay. So these are some of the categorical data. So what are numerical data? Numerical data is pretty obvious. Price, you can give a value to it. Any numerical data, for example, salary, weight, age, height, yes, marks, yes. So all these are like numerical variables in your data set. Okay. So these are numerical data. So when your data set only has numbers, it is like kind of a numerical data set. When your usually doesn't, it is not the case. It is a mix of both categorical and numerical variables. Okay. For example, your scorecard of this class, after first formative exam of data analytics. So the scorecard is like first person. All the person names will be there, and the second column will be which branch they are from. MSc Data Analytics and Computational Science, Computer Science with Data Analytics, Geoinformatics, okay, Data Science and Bio AI. So all those four different things, which group wise, okay, and what is the first formative mark. So the data science, DSES, CSDA, GIS, Bio AI, all those are categorical variables. Your names are also categorical variables, but the marks are the numerical variables. Okay. So those can be real numbers. 35.5, 38.4, not necessarily integer, they can be real numbers. Okay, but they are numerical. Okay. What you can do with those numerical sets, that further classifies into multiple types of data. Okay, you can further classify this numerical data as discrete and continuous. Can you give me an example of a discrete data set? For example, your age. Every year, your age increases by 1 in a discrete way. But when you ride a motorcycle, your velocity, or the truck or the train or the aeroplane velocity, the velocity is a continuous quantity. Where there is an acceleration, it is a continuous quantity, right? You accelerate. There is an accelerator in your bike or your car, and when you accelerate, it is the rate of change of velocity. Okay, so that means velocity is changing in a continuous way. Okay, so those are like weight, voltage. Voltage also is a continuous variable because current is rate of change of voltage, right? dV by dt, right? So therefore, voltage changing continuously. Fine. I hope it is clear. Now, levels of data measurement. There are different levels of your data measurement to be done. So you can see qualitative and quantitative data measurements. In qualitative, when you have qualitative variables, you can further boil it down to two classes. That is nominal and ordinal. Nominal is the lowest one. Nominal is the lowest data level. Okay, and ordinal is above it. For quantitative case, when you deal with numerical sets and all, you are coming to interval and ratio data. Okay, interval data and ratio data. So ratio is the highest one. Ratio data, ratio level of data is the highest level of data. Okay, so we will see example of each of them. So let us come to each of them. So nominal. Okay, so nominal, you can see nominal data level is such that it classifies data into distinct categories in which no rankings are involved. So these are such categorical variables in which no rankings are involved. For example, can you tell gender, male, female? I mean, yes, but you don't usually say male is greater than female or female is greater than male, right? No rankings are there. Okay. Any example? Marital status, like married, unmarried. Okay. You cannot compare. You cannot say that the ones who are not married has a lower value than the ones who are married. Okay. The people who are married are not happy, and the people who are not married, they are pretty happy, right? And sometimes it's other way around also. People who are not married, they are very happy. Sorry, they are very sad, and people who are married, they are very happy. So it depends. We cannot make a claim or a ranking that yes, married is greater than unmarried or unmarried is greater than married. Fine. So these are just the categories or levels. There is no inherent order. That's an idea. There is no inherent order in your nominal data level. Okay, in nominal data sets, there is no inherent ranking. That's the idea. Okay. So what kind of things, what kind of analysis or analytics can we do on these nominal data sets? In these nominal data levels? Can you take average? Can you take an average of unmarried and married? You can take average of 5 and 6, but you cannot take average of unmarried and married. Okay. So therefore, when you take a mean, when you talk about mean of a nominal data level, it doesn't make sense. When you take a mean or median of a nominal data level, it doesn't make sense. But what can make sense? Yes, exactly. I think you already know about this, right? Already. Mean median mode you already learned where? In bachelor's? Okay. But here you will see something a bit different. I mean, the ideas will be the same, but something a bit different, different taste. Okay. So of course you can do mode. You see, this is the reason why I wrote mode and not mean and median. You can tell from the given data set how many are married. So you can take a mode. So in my data set, I want to know how many maximum number of people are married or unmarried. So you take a mode of that. So it will tell what is the maximum number of occurrences that they are married. If the maximum number of occurrences comes out to be unmarried, then in your data set, lot of your customers are unmarried. That's the idea. So mode makes sense. Okay. You can also do frequency tables, of course, because the highest frequency gives you the mode. Highest frequency of that variable gives you the mode. Bar charts. You can further do bar chart scenarios. Okay. How you can do bar chart scenario? How many people are unmarried? How many people are married? And in which age range they are? What is the age range? Also, you can further subdivide. Okay, from 20 to 25. What are the number of unmarried people? What are the number of married people? From 25 to 30, what is the scenario? Like this. You can visualize. I mean, for nominal data, you can do mode. You can visualize them using bar plots also. You can do pie charts. So this is one of the most important thing. Pie charts you can easily visualize for categorical variables. Okay, line charts, bar charts, all these things you can do scatter plot for numerical variables. But keep in mind very clearly that pie chart is very nicely famous for categorical variables. If you have categorical variables, and maximum times we see numerical data to visualize. We don't have usually categorical data in scientific disciplines. But when you have categorical data, then one of the most basic plot you should reach out to is a pie chart. So I told you, you will learn different methodologies, but when to use when will be important. So if you have a categorical data, will you use line plot? No. Will you? So you will use a pie chart, right? So therefore, you should know when to use when. Okay. Let's come to the ordinal data set. So it classifies data into distinct categories in which rankings are involved. So it is a kind of a categorical variable in which ranking is involved. So nominal variable ranking was not involved. In your ordinal one, ranking is involved. Okay. So you can see student grades A, B, C, D, E, F. Of course, A is better than B. Of course, grade A is much better than grade B, right? And you can see there is a ranking. There is a ranking involved here. Okay. Product satisfaction: satisfied, neutral, unsatisfied. Of course, satisfied is greater than neutral. Neutral is greater than unsatisfied, right? I mean, you will prefer the customer to be neutral rather than unsatisfied. That's the idea. Okay. So you can have rankings here also. But remember, these are all categorical. These are all categorical variables. Okay. Fine. Interval scale. So it is an ordered scale in which the difference between measurements is meaningful, but the measurements don't have a true 0 point. So this is a sort of numerical data level in which differences between the measurements is meaningful, but they don't have a true 0 point. Okay. We don't know where what, like 2025. Okay. So year zero is kind of arbitrary. Okay. Year zero is kind of arbitrary. So difference between 2000 and 2010 is meaningful, that there are 10 years has passed by since then. But year zero is doesn't make any sense because year zero is kind of arbitrary. Okay. So temperature in Celsius and Fahrenheit, you can see 0 degrees Celsius. We cannot say that it is no temperature. Okay. So kind of these examples you can have a fresh of mind. So some examples can be given to you, and you will be asked whether it is ordinal or nominal or categorical, something like that, in your exams. Okay, some examples will be given. You will be asked whether it is ordinal, nominal, interval, or something. Fine. Ratio scale is the topmost. Okay, in the data level. So what you do, it's an ordered scale, and in which difference between the measurement is a meaningful quantity, but here the 0 point holds meaning. Previously in in interval data, it doesn't have a true data point, but this have a true data point. You see the difference between them. Okay. Can you tell me an example? Weight, of course. Zero weight means it's weightless. Zero weight has a meaning. Okay, zero weight has a meaning. So weight comes under ratio scale. Okay. Salary, zero salary means you are not employed, right? 10,000 salary means you are employed with 10,000 number. Okay. Your salary increased by 10%. So 10,000 to some 10,100 rupees, something. So 100 rupees increase, kind of. Okay. So there you can see difference makes sense, and they indeed have a true 0 point. Okay. So in ratio scale of data levels, you can perform all sorts of arithmetic operations, be it multiplication, addition, subtraction, division. You can multiply weights, you can add weights of two people, you can subtract weight of two people to see which one is weighing more than the other. Okay, you can divide the weight also to see this person is how much times more heavier than the other or weight more than the other, right? Fine. So, okay. So you can see all arithmetic you can do. Ratio makes sense because 100 kg is twice 50 kg. Okay. So you can do all kind of data analytics in this. Like mean you can apply in a given data set. You want to understand what is the mean weights. I want to understand in boys what is the mean weight. What is the mean weight of the boys in this class? So what you do, take all the weights of the boys and divide by the number of boys. That will give you the mean of the weight, right? Standard deviation. From the mean, how many boys deviate from that mean? Okay, how many boys have weights that deviate from that weight? I hope you are getting some connection. Okay. Geometric mean, coefficient of variation also you can perform. So this is the order scale here. Okay. For you to see, let us see this one first. So in nominal, there is no order. Okay. They don't have to be in equal interval. For example, gender, eye color you can use. You can use mode in that. You can count them. Okay. Whereas in ordinals, they don't have a true zero. Okay. And class rank, for example, you can do, they have a ranking in between them. Of course, you can rank them, you can take a median of them. Okay. How many in the class scored A grades? Okay. What maximum grades is scored in the class? Maybe A plus. Okay. Something like that. Okay. Fine. And you see, this is the level. So this is the level. Okay. So you can see the highest level of data is the ratio data. Okay. In which you can compute, you can perform all kind of arithmetic operations. Okay. All kind of arithmetic operations you can see here, and ordered, or it is ordered as well as they have a true 0 point. Whereas for interval, they are ordered, but there is no true 0 point. Okay, fine. In ordinals, it is ordered, but there is no equal spacing. Okay, sorry, this error here. In nominal, of course, there is no ordering. There is no ranking involved in nominal data set. Good example is eye color. Like, so someone has green eye color, someone has brown, someone has black. You cannot say that this is greater than this is greater than that, right? Fine. So this is the idea so far. Okay. What we can do is take a quick break, and we'll meet after 15 minutes. Sound good idea? After that, we will start with something else and some new topic, and let's see.